All right, so we've been spending a lot of time graphing sine and cosine. And so what I want us to do is spend time on just kind of using our bell work to look at what does sine and cosine graph look like, things that are pretty distinct to just their type of graph, and some of the features that come with their shape. So we've looked at sine graph, and sine's the one that kind of looks like a sideways S, like a wave. I mean, I guess to me they all look like waves, but sine is specifically the one that looks like an S to me. So what I'm going to do is drop some intervals down. I like to use 0 to 2 pi, and then go by every half a pi. And so in this case, sine, again, is the one that it starts at 0, but can go up to +1 and -1. So at 0, it's 0. At pi over 2, it's at 1. And then at pi, it's back to 0. And so forth. So I'm going to draw my curve here. Oops, I think I drew the last one wrong. Should be right there. And so, like I said, the curve looks like kind of like an S, but sideways. So it looks like the minimum here is at y equals -1, whereas the maximum looks like it is at y equals 1. And my amplitude here is just talking about the height from the peak or the trough. So either the highest point or the lowest point from the x-axis, because that's the midline here. So in this case, my amplitude is just 1. That's only 1 unit. Whether you're going from -1 to 0 or 0 to 1. Only 1 unit for the amplitude. And also the sign here, the coefficient in front of sine is 1. So you know that the number in front is also your amplitude. And amplitude, just as a quick reminder, is the absolute value of A. Okay, now for cosine, if we do it from 0 to 2 pi, I'm going to cut this in half. This would be 3 pi over 2. This would be pi over 2. Highest point was 1. Lowest point is 1. -1. And so for cosine, it starts at +1. And then, oops. Let me grab my pen here. There we go. Starts at +1. Then it goes down to, I think at pi over 2, it goes down to 0, and then pi, it goes down to -1, then back to 0, and then starts back at 2 pi again at 1. So when you draw this curve here, it kind of looks like a U shape, right? And so you can see that the minimum here is also at y equals -1. The maximum, you have like 2 maximums here. Highest points at y equals 1, and the amplitude. So the amplitude still is referring to from the distance from the x-axis. So from here to here. Actually, let me reiterate that. So it's the distance from the midline or the halfway point of the curve to the highest point or the lowest point. So in this case, the midline here is the x-axis, and from the x-axis to the maximum point, that's about 1 unit. And from the x-axis to the minimum point, that's also 1 unit. So the amplitude is 1, but also you can just look at the cosine and you can see that the amplitude or the coefficient in front is a 1. All right. Kind of to tie everything together here, I want to explain today about wavelengths and how you measure the length. So wavelength is what we call the period. So in this case, these periods here, both of these graphs periods, go from 0 to 2 pi. So this one full cycle of sine is about 2 pi long. Basically, the length of this cycle is about 2 pi. Because we know that sine graphs will keep on extending and going on forever and ever. Like it can keep flowing, and same thing with cosine here. It can keep going on and on forever. But if you were to just take one cycle of it, or one complete revolution, that revolution is about 2 pi of length. So we're going to look at different types of periods or different types of wavelengths to see how that affects the graph. All right, here's the next slide. So again, wavelengths or period is the wavelength of a full cycle. So period is talking about the wavelength. And when we're talking about period, we're talking about this b value here that helps us calculate the period. So the period formula is 2 pi over b. And we're going to use this in the next slide here. So here's our first problem. These are suggested homework problems. I'm going to pull a few from that section, 17.1. So here's problem 5, and you're going to graph the trig function. And so in this case here, this trig function is sine 2x. And so we're going to figure out what happens when you make the inside of the parentheses have a coefficient next to the x. So in this case, our x here is 2. That's also our b value, right? So in this case, my period, if I were to calculate it by hand, be 2 pi over b, which is 2. Well, since there's a 2 in the top and the bottom, they would cancel and become a 1. So you really have, 1 times pi is pi over 1 is just still pi, so just pi. So my period is pi, but I still don't know exactly what that means. And I'm going to show you what that means on the graph. The amplitude here, you can see that the coefficient in front of the sine is a 1. So you can probably already know that this amplitude is a 1. So when in doubt, if you don't know how to graph, you would make a table. Now I'm going to help us out by creating the x values that I would suggest to plug in. But later on in the next slide, I'm not going to make a table anymore. In fact, what I'm going to be doing is using sine and cosine's original graph and shifting it based off of what the equation tells me the shifts are going to be. So I'm going to try to avoid using the graph as much as the table as much as possible, so that way I can get you guys seeing the patterns and how to shift your graph. It also makes it quicker too. So I'm going to choose values like 0, pi over 4 this time. I'm going to go every quarter of a pi. So then this would be pi over 2, 3, pi over 4, and then pi. I think that's enough. 4 points is good enough. And so if I were to plug this into my function here, it'd be 2 times 0 inside, 2 times pi over 4, and then sine 2 pi over 2, sine 2 times 3 pi over 4, and last but not least, 2 times pi. And so in this case, if you just work out the inside first, before I even use the unit circle here. So sine of 0 is, 2 times 0 is 0, and so sine of 0 is 0? Feel free to check the unit circle, but I'm pretty sure it's 0. Sine of 2 times pi over 4. So pi over 4 will cancel, with the 2 and the 4 will cancel each other, so that would mean 2 goes into 2 one time, 2 goes into 4 2 times. So this is really pi over 2. Sine pi over 2 is 1. The next one, the 2's cancel when you multiply, so now you're just left with sine pi, and when sine is pi, it's 0. 2 times 4 gives you, let's see, 1, and then 2 goes into 4 2 times, so this is really sine 3 pi over 2. And so sine 3 pi over 2 is in the lower quadrant, so that's -1. And then sine of 2 pi, because 2 times pi is 2 pi, is 0. And so what I'm going to do is graph these values. These are my y values, so I need to pair them up with my x values. So 0, 0 is my first point. So let me make us a coordinate system first. So this goes to 0 to pi. I'm going to cut this in half and then put the other point. So this would be pi over 2, pi over 4, 3 pi over 4. And that looks like all my points. The highest point here looks like it's 1, and the lowest point is -1, so that helps me out with the y-axis. It's a little low. Let me bring that up just a little bit. All right, so I'm going to plot my points now. So the first point's at 0, 0. The second point's at pi over 4, then 1. So that's up here. And then at pi over 2, it's at 0, so back down to the x-axis. At pi 3 pi over 4, it looks like it's -1, so I'm going to plot it down here. And then when sine is pi, it's back to 0. So notice that when I graph this looks very similar to a sine graph. Actually, let me draw us a sine graph real quick to see what that is in comparison. So the sine graph goes from 0 to 2 pi. And so when you draw a sine graph, the wavelength of an original sine graph, or the period for just sine of x, is 2 pi. Let me write that here. So the period here is 2 pi. Whereas this period here is half of that amount. It's pi. So that means that this wavelength will have one full cycle from 0 to pi. That means I could draw another cycle and continue that pattern. Do that again, just nicer. There we go. And then when it hits here, it would be about 2 pi. Because from here to here, that's about 1 pi, right? So basically what I'm saying is that this picture goes from 0 to 2 pi and there's one cycle. For this equation, you could fit 2 cycles between 0 and 2 pi. So if you were to like overlap these, you would have sine going from here to here, and then you could fit 2 of these cycles inside of it. Kind of cool. All right, so in the next slide here, we're going to do it without a table. Okay, so first let's go calculate the period and find the amplitude. So amplitude here is just going to be 1 because the coefficient here is 1. Period, I'm just going to call that P, is 2 pi over B. B here is, again, 2. And so that's going to cancel, leaving this as just pi. So my period here is pi, which tells me that the wavelength, or one cycle, is going to be a length of pi. All right. So here's the benefit of figuring out your amplitude. Your amplitude tells you what is your highest x value, your highest y value and your lowest y value. So the highest y value is going to be 1 and the lowest y value is going to be -1 because the amplitude is from the midline. So it's going to go up 1 and down 1 for the min and max. And then for the period, it helps you tell you your x-axis. So the period is about the length of pi. So I know I have to go from 0 to pi. I'm going to place pi here. And then I'm going to try to cut this into 4 segments. So this would be pi over 2, pi over 3 pi over 4, and then pi over 4 on this one. And the reason why I do this is because if you look at the original graph for sine or cosine, you kind of cut it into 4 pieces, right? Like you would have 2 pi, this would be pi, this would be 3 pi over 2, and this would be pi over 2. And so when you do this, let's kind of draw a quick graph of what cosine's graph looks like, so that way we can just remember the shape. And so in this case here, you have it from starting at 0, then it goes down to pi over 2, then at pi it's -1, then back to 3 pi over 2, and then back to 1. So if you draw this curve here, you make that U shape. And so we're going to make that U shape here, but it has to be from 0 to pi for one cycle, whereas this one's from 0 to 2 pi. And so when I draw this cycle here, I'm going to start at 1, and then at pi over 4, well, that's very similar to what happens at pi over 2. So I go down, and then I'm going to go really far down to -1, then back to 0, and then back to 1. And so if I draw my curve, I make that U shape, but again, this is only from 0 to pi now. So if I were to extend this to 2 pi, I could do it again, and I could put the intervals in here, but I'm not going to worry about that too much. But what I'm saying is I could fit another one of these in here. Let me do that better. Go down, then back up, and then pause at 1. So I can fit 2 of these cosine cycles in one of the originals. And that's it. That's how I can do it without the graph. So the period, it kind of helps you with your x-axis, and the amplitude helps you with your y-axis. All right, so this one's 23 here. So this one, sine, has a 1/2 inside, so this is my b value, okay? And so that means my period here is 2 pi over 1/2. Well, if I were to work this out, I could also just, understand that this would be dividing by a fraction, so I have to flip it, multiply by the reciprocal. So it'd be 2 over 1. And then I could put this over 1 and then multiply this straight across, which would make it 4 pi over 1, which is 4 pi. So this is 4 pi. The amplitude here, it looks like it's a 1. And so if I were to draw this graph here, I know that I'm going to have a highest value of 1, lowest value of -1. And it's going from 0 to 4 pi. 4 pi is my period, which is the wavelength. So this, it gets really stretched out. It's really wide compared to the original, which goes up to 2 pi. So now what I'm going to do is make sure there are 4 interval spaces or 4 markers here. So maybe this will be pi since it's between 0 and 2 pi. And then this, I guess, has to be 3 pi since it's between 2 pi and 4 pi. So this one here is the sine graph, and the original sine graph looks like 2 pi, pi, 1, and -1. So like this, right, where it's going from 0 to 2 pi. Now, in this case, I'm going to draw that same shape, but it's going from 0 to 4 pi. So when I draw this curve here, it's going to start here. At pi, it's going to be at 1. At 2 pi, it's going to be down to 0. 3 pi, it's -1. And then 4, it's going to be back to 0. And there we go. That is our sine curve for 1/2 x. So I'm going to, just for funsies, I'm going to draw what it would look like if I were to fit, a regular sine graph in this same graph. So sine would actually look like this. Let me mark this. So this is y equals sine 1/2 x. So now I'm going to draw the other one. So it'd still be at 0, 2, then 1. It would be here, and then it'd be here. So basically, it would look like here, and here. There we go. So regular sine would be, you could fit 2 of regular sine in sine 1/2 x, if that makes sense. All right, let's do a few more example problems. Okay, so here we have a amplitude of 3, and so remember, amplitude is just the absolute value of a, so the absolute value of 3 is still 3. So you can just honestly write a 3 here. So amplitude, you always take the absolute value of. The period here is 2 pi over b, so this is over 2, so again, this looks like our period, again, it will be pi. And if I were to make my graph here, I know that my y-axis is now going to have a maximum of 3 and a minimum of -3. And it needs to go to at least pi. So I'm going to make sure I stretch out to pi. This will be 3 pi over 4, and this will be pi over 4. And so if I draw this curve here, this one's a sine curve, so we're going to start from the origin. And then the next part here, pi over 4, is going to be up here where the maximums is, and then it's going to come back down, then go to -3, and then back up. And then I draw my curve. And so I could extend this again if I wanted to. And then if I were to land right here, this would be at 2 pi. Because one cycle is about pi length, right? 1 period's pi length. So from here to here would be adding a pi. So that leads you to 2 pi. All right, let's do one more problem. So this problem here is a lot of things to consider. Like this negative sign here flips the graph. The 2 here tells me that this is my amplitude. 3 here tells me my period, or it's my B value. So my amplitude here looks like it is, so remember amplitude is the absolute value of A, which is absolute value of -2, which is +2. The period here is going to be 2 pi over 3, and I can't simplify that any further, so this is really just 2 pi over 3. All right, so now I'm going to try to draw my graph here. So because my amplitude is 2 here, I know my maximum is going to be 2. And my minimum is going to be -2. And then my period goes from 0 to 2 pi over 3, so I'm going to make this go out to 2 pi over 3. If I were to add another one, this would be 4 pi over 6. Actually, I'll do that later. I don't really need to do that right now. Okay, so if this is 2 pi over 3, if I cut this in half, what is 2 pi over 3 cut in half? So you can multiply that by 1/2 to do that. And so this would be 2 pi over 6. And if you divide that by, if you reduce it, that's going to be pi over 3. And then you could create the other tick markers, but for now I don't really need them. It really just helps if I know where the middle mark is and where does it extend to. So 2 pi over 3 is where it extends for a full period. So in this case here, cosine is the one that looks like it starts at the, actually let me draw the cosine graph to help us out. So this one goes from 0 to 2 pi, maximum at 1, -1 for minimum. So it starts at the origin, starts at 1, then goes down, back up, and then back up. So in this case here, I need to start at 2, but hold up, this is a -2, so that means everything gets flipped. So this is going to be down here instead. So everything's going to be opposite. Then at, this middle part here, it's going to be back at 0. At pi over 3, it's going to be up at 2, and then go back to 0, and then back to -2. So everything's flipped here. And there we have our U shape, but it's upside down because there's a negative sign, and that's it. Now, if you want to continue to extend this curve, you can. Okay. And then if you wanted to figure out what this value is, just add 2 pi over 3 with another 2 pi over 3, because you know that that is also another 2 pi over 3 cycle. So this would give you 3 over 4 pi. So 4 pi over 3. All right, that's it for this journal. For next time, I'm going to add more to this journal to extend some practice problems. So stay tuned for that video.